Hi, hello friends. Welcome to T Academy. In this video, I want to discuss exam pattern of TNEB, Tangentco or Transco Assistant Engineer exam, and this exam is conducted by TNEB, which will have total 100 questions here. Okay, 100 questions, which is divided into three parts here. So part 1, part 2, part 3. So part 1 20 questions, part 2 20 questions, and part 3 60 questions, which belongs to the basic engineering streams of the candidate. And these two will be general studies, and this one will be 20 marks will be for the basic engineering, okay, basic physics or chemistry, like that. Now I want to give a view of how the examination paper will be, not exactly, okay. So just give me a model paper here. So I'm giving this 60 questions model paper for you, those are preparing for the TNEB, TANGETCO or TAN Transco electrical branch examination point of view. Okay, and one more point here, while you are watching this video, don't download this video, just see in the YouTube itself, and when I read the question, I will give a 1 or 2 seconds pause. At the time, pause that video and try to solve from your side. So why I am saying online, because your exam will be online mode, so that while you are doing examination, okay, so you will have a real-time atmosphere of reading the question and doing that. If you are downloading, means what you will do is generally you will become some give extra time, okay, we will do it later, like that. So don't do that. So along with me, try to solve the question and try to analysis your preparation levels. Okay, that is my important point here. And this video or this question paper will have a 60 questions. Okay, and each question will carry 1 mark, 60 marks here, and a negative mark for one and a half. I mean, negative mark is there for one third of each question wrong answer here. So for every 1 mark, 1/3 will be negative here. Okay, and in this paper, I am only discussing the part 3 technical paper only. I am not discussing the general studies paper and basic engineering paper here. Okay, now we'll start the question here. Okay, so while once you know the answer, just take a piece of paper and write your answers, so that at the end of the video you will came to know how is your preparation. So this paper is somewhat easier compared to what you are going to write in the tangent examination or transco examination. Okay, right, let's start the video here. Okay, and these questions are strictly related to your syllabus, and these are not beyond your syllabus. Okay, now first question here. In a series RL circuit, the switch is closed at t is equal to 0. The value of the current at t is equal to 0. Okay, now pause the video and uh, do your answer. Okay, and make the option here. Okay, I will solve the answer here. So all of you done that. All of you have done the answer here. Okay, so here I will do the answer. First of all, here the concept is 10 volts is here, 5 ohms is here, and 2 ohms here, and 2 Henry is here. And this is the question from the transient subject. When the switch is closed at t is equal to 0. So when the switch is closed at t is equal to 0, at t is equal to 0 minus, tell me, switch is in open state or closed state? So switch is in open state, open switch. At the time the current is flowing like this, and we know that at t is equal to 0 minus steady state condition. In steady state condition, inductor means L act as a short circuit. So now check your analysis. Okay, now 10 volts is here, 5 here, and 2 here. Inductor simply act as a short circuit. Now what is the current here? So be simple KVL loop. I will write here minus 10 plus, let the current here I, so 5 into I, and this will be here, plus 7 into I is equal to 0. So from this I is equal to, we get it as a 10 by 7, okay, amps. But the question is the value of current at t is equal to 0. So at t is equal to 0 means just when you close the switch. When you close the switch, this 2 ohm resistor becomes short circuit. Yes or no? Yes, short circuit. Now the current will be 10 by 2, 10 by 5 is nothing but 2 amperes. Is it right? No, that is wrong. Why? Because inductor will never allow sudden changes in current. That should keep it this point. At t is equal to 0 minus what is the current? at t is equal to 0 plus the same current will flow. That is the point you should understand here. Okay, I'll write this point here. Inductor will never allow sudden change in current. So this is the concept you need to understand here in this problem here. Okay, so based on this, the answer will be C. So check your answers. If you are getting a C answer, right, you have the concept. Next one here. Okay, the bandwidth of a low pass filter is 1 kilohertz. What is the rise of time of the output for a step input? So solve the problem. Okay, so I will tell the answer. Now the important formula here is the bandwidth into rise time is having a constant. This is 0.35 here. Now I want TR is equal to 0.35 divided by bandwidth. So 0.35 divided by 1000. So it is nothing but what? 0.35 milliseconds. So answer is, yeah, yes, is a right answer for this question. Next one here. Okay, as you can see, the value of a the value of a parameter A for the two-port networks shown is, we need to find the ABCD parameters. We need to find here A parameter here. Okay, now solve the problem. Okay, so the answer is 1 here. I will explain how it is, why the answer is 1 here. Now, in a two-port network, the basic formula is Vs is equal to A into Vr plus B into IR. They ask you to find the value of A. A is nothing but Vs by Vr when we made IR is equal to 0. So in this case, let us assume this will be Is and here this will be IR here, and the voltage will be Vs here, second set voltage will be Vr here. Now A is equal to how much voltage here? Is is flowing here. Whatever the IR is 0. So from this we can say if the current is 0, the voltage drop across here is 0 volts here. If you apply KVL also, what you get? Minus Vr plus 0 plus the voltage across here. That's nothing but Vs. So Vs is equal to 0. Now what is the relationship? Vs is equal to Vr. Now A is equal to Vs by Vr. That's nothing but 1. Hope you got the answer. It is 1. Next question. Okay, right, this one. In a two-element series circuit, the applied voltage is V of t is equal to 100 sin omega t, and the current flowing is I of t sin omega t minus 45 degrees. Then the value of the resistance and reactance of the circuit are. Now pause the video and solve the problem. Okay, so I will do the answer. So the answer here it is A is the answer. Why it is A? Now the angle between the voltage and current is, what is it? 45 degrees. Okay, 45 degrees. Is it leading or lagging? With respect to voltage, the current is lagging by how much angle? 45 degrees is the current here and voltage here. So voltage leads the current means it is a inductor. So inductor means always power factor will be lagging. Okay, now we need to find the value of Z here. So Z is nothing but voltage phasor by current phasor is nothing but 100 divided by 10, which is nothing but 10 ohms we got here. Now we need to find R value. Okay, so cos theta is equal to R by Z. So based on this formula, we know Z value. So R is equal to cos 45 1 by root 2 into 10. So it is nothing but 0.707 ohms. Similarly, we are going to find reactance. Reactance sin theta is equal to R by Z is equal to, sorry, sin is X by Z. X is equal to sin 45 into 10 is nothing but J again 0.707 ohms. It's in magnitude. Reactance will have a positive sign here, plus sign. Negative sign means is capacitive reactance here. So answer is A here. If you want to know the triangle, you can draw the triangle here like this. Here you can take the angle theta. It's a R here, and this will be reactance X, and here we have Z. So from this we can say cos theta is equal to R by Z here, R by Z. Now we'll move to the next question. Okay, in a AC circuit, the Thevenin's voltage is 10 at an angle 30 degrees volts, and Norton's is 2 at an angle 60 degrees amps between the load terminals. The value of the load impedance to have a maximum power transfer to the load. So okay, Thevenin's voltage is given, Norton's current is given. Okay, so first of all, source impedance ZS is equal to, so VTH divided by ISC. So based on this, 10 at an angle 30 divided by 2 at an angle 60. So 2125 here. So 5 at an angle minus 30 degrees is the answer. Okay, if you are getting the answer 5 at angle minus 30, it's a wrong answer. Why? Because the value of the load impedance is, we know that to get a maximum power transfer, ZL is equal to ZS conjugate. That implies the load impedance should be equal to, okay, so 5 at angle conjugate means it becomes plus 30. So answer is A here. Okay, check your concept. If you're getting A is a, if you're getting A is the answer, then you are right. Okay, we'll move to the next question here. Okay, next one. A synchronous machine connected to power system grid bus bar is operating as a generator. To make the machine operating as the motor, then what is the necessary answer here, step here? Generally, in case of alternator, which will have excitation here, which is connected to bus bar here. Okay, bus bar means constant voltage, constant frequency is there. Okay, now what happening is the alternator will take the mechanical energy, okay, which will convert the mechanical energy into electrical energy here. Now it has to make a reverse process, means electrical energy should be more compared to mechanical energy input, equivalent input here. At that time, what we will do is we will reduce this mechanical input is lesser than, mechanical input is to be less than the loss of the shaft, so that mechanical energy is very less. At that time, electrical energy is greater than that of compared to mechanical energy. At that time, the machine behave as a motor. Okay, so the answer for this question is mechanical input to be less than the losses of the shaft here. Okay, if you're getting a D is the answer, then you're right. Next one. So read the question and select the answer. A smaller air gap in a polyphase induction motor helps to. Okay, so in induction machine, the air gap between the stator and the rotor is very less here. Okay, so it is because to reduce the magnetizing current here. So for the seventh question, the answer is reduce the magnetizing current. Okay, so reducing the magnetizing current is the right answer. Next, we'll go for the next question. Yes, next one here. Eighth question, read the question carefully. A 2 kVA transformer has iron losses of 150 watts and full load copper losses of 250 watts. The maximum efficiency of the transformer would occur when the total losses is. Okay, tell me your answer. Right, if you are getting the answer as C, then your answer is right. Now the explanation part. Okay, so transformers has having a maximum efficiency when the core losses is equal to copper losses. Okay, when we are discussing the previous not previous, very important formulas of electrical machines in transformers, I said this point here. So copper losses are made equal to core losses. Generally core losses are how much? 150. Now copper losses, whatever it may be, this value 250 or something value, we will make it to equivalent to 150. Now 150, 150. What about total losses? So total losses W total loss is equal to eddy current losses plus iron losses plus copper losses. At that time, it is equal to 150 plus 150. Answer is 300 watts. Okay, next one. So in this question, the voltage is here, right? The graph represents which of the following characteristics of DC generator. Okay, so here some mistake is here. Okay, typing mistake, voltage and current here. Now the answer for this question is external characteristics. The external characteristics are drawn between the terminal voltage and the current, load current IL we can say, and it will have a drooping characteristics here. So drooping characteristics are available in only external characteristics. So the answer is B here. Next question here. In an electromechanical energy conversion device, the developer torque depends upon. Yes. Guess the answer. Yes, the answer is C here. Okay, in electromechanical energy conversion device, the torque is proportional to phi m1 into phi m2 into, you can say, sine phi here. That means directly you can say the stator field and rotor field strengths and the torque angle here. So phi is nothing but a torque angle here. Okay, so answer is C here. Next question. For the quality factor, when the voltage across the capacitor is 1000 volts and the source voltage is 100 volts. Okay, so those who are saw my digital assistant model paper, then you can easily solve this paper, solve this question here. Okay, see here. Find the quality factor when the voltage across capacitor is Vc is equal to 100 volts. So this question is I already solved in my digital model paper, digital assistant model paper. If you want, you can go through that paper also. Now, what is the quality factor? Q is nothing but ratio of Vc by V here. Okay, so Vc is 1000 divided by 100. You'll get as a 10. So answer is yes, A is the answer. And the next one. In a circuit, resistance of 5 ohms is connected with a capacitor having a capacitor reactance of 12 ohms. Supply of the 260 volts is connected to the circuit. Calculate the voltage across the capacitor. Okay, so pause the video and do the solution. Okay, so I'll give the answer. So answer is C, 240 volts. Okay, if you want the answer for this question, just refer my previous video of digital assistant model paper in which I discuss the same question here. Okay. Next question. Which one among the following has the highest numerical value in a stepper motor? So highest numerical value is nothing but a determinant torque. So what is this determinant torque? Is determinant torque is going to hold the position of the rotor at the same place when there is no electrical supply given to it. Okay. So holding torque is nothing but just like a holding, I mean applying, suppose if I will take analogy of the two-wheeler or four-wheeler example, four-wheeler in which you have a applied brake. When you are applying the brake, the vehicle will is in stop position. Okay. Similarly, determinant torque is nothing but applying the extra brake. Okay, so which is available in the front side. What we can call that one as a parking brake, right? No, what I want to say is holding torque is available when the current or power supplied, when the power supply given, but determinant torque is available when no power supply. So answer is A here. Next one. The result of a slip test for the direct axis and the quadrature axis reactance of a star connected silent pole alternator are given below. Phase values Vmax, V minimum, Imax, I minimum given. Hence the two reactances will be. So tell the answer here. So answer is 11th one, 14th one is D here. So I will write the formula here. First we'll find the XT. The formula for XT is V max by or minimum. XQ will be V minimum by I max. So V max is 108 by 10 is nothing but 10.8. So 1 you got the answer. XQ will be 96 divided by 10. 96 divided by 12, sorry, 12. So it is 8 ohms here. So answer is 1 year. Okay, next question. Now here we need to find the current flowing in the ammeter I. So take the problem and solve it. Okay, so the answer is for this question is it will be 0.5 amps. Now how you got the answer is when you are placing an ideal ammeter means ideal ammeter act as the internal resistance should be is equal to 0. It act as a simple short circuit. When a simple short circuit occurs, this entire block act as a short circuit. Because of short circuit in parallel with resistance will be negligible 0. Now here what we need to do is we need to find the current. Neglect this resistor, neglect this resistance here. Okay. Now the current will be flow like this. This will be neglected. Now the equivalent circuit will be so 9 volts. Now these two become parallel. So parallel combination of these 6 ohms and 6 ohms will become 3 ohms. Why? Because 6 in parallel with 6 can be written as 6 into 6 by 6 plus 6, 36 by 12. How much? 3 ohms here. Now it is in series with how much? 6 ohms. Now R equivalent will be 6 plus 3. How much? 9 ohms. Now I need to find current. I is equal to V by R equivalent. V is how much? 9. So 9 by 9, 1 amp. Now the 1 amp current will flow from here. 1 amp current will flow. Now it is divided to two parallel paths. No? So it's divided if you apply current division rule. Okay. So I 6 ohms is equal to entire current to 1 ampere into opposite resistance divided by total resistance. How much? 12. So it's nothing but 0.5 ampere. Once the 0.5 ampere current flowing here, remaining current how much here? If you apply KCL, 1 ampere is coming, 0.5 is going here. How much remaining here? So 0.5 ampere is going. So the 0.5 amperes will go like this. It will come back. Okay. Now here will be 0.5 amperes and from here 0.5 entire current will be 1 ampere. So answer is 0.5 amperes answer. Okay. So you got the answer as 0.5 amperes. Now next one. So till now we discussed about the networks. Now we'll discuss about the digital electronics. Okay, important for our exam point of view. The gate whose output is high when all the inputs are low. Okay, the gate whose output is high when all the inputs are low and the output is low for all the combinations of input is which gate it is. Okay, so pause the video and tell your answer. Okay, answer is it is NOR gate. How it is, sir? Let me take A, B, and I will take an OR gate here. Next, I will take NOR gate. 0 0 0 1 1 0 1 1 inputs are taken. OR gate means 0 1 1 1 here. NOR gate means 1 0 0 0. The gate value whose output is high when the inputs all are low. Okay, is satisfied. And the low means 0 value for all other combinations. So answer is NOR gate. Next question here. How many and OR gates are required to realize a function y is equal to cd plus ef plus g? Okay, so pause this video and tell your answer. If your answer is A, then it is the right answer. Now I'll explain how it is. First, I will take an AND gate. If I take AND gate, the inputs must be C, D here, so that I can get a CD here. Next, I will take one more AND gate here. I will give E, F. The output will be what? From these two gates, it is EF here. Now, we will add these two values with the help of a two input OR gate. What will you get? C, D plus EF. Now, I will take one more OR gate here to add this value. So it's not an AND gate, so it is only OR gate. Okay, understand here, OR gate here. Now I will connect with the G here so that CD plus EF plus G here. So how many? 1, 2 AND gates, 1, 2 OR gates. So answer is 2 2. Next one. Now this is very simple question. For the circuit shown in below, the equivalent logic gate. Yes, the answer is R. Why? Because if any one is a positive, it will conduct. The output will be appear here as something say V naught. Okay, if any one switch is on, output will get as a V naught. Okay, so answer is any one switch on means OR gate. You have seen the truth table of this. You can, if you want, you can review this here. Now convert 214 base H into a decimal value. Now how are we going to convert this octal value here? Yes, what will be the answer here? So answer for this question is A here. Yes, the answer is 140. Now octal to decimal conversion is obtained by multiplying H to the power of base index along with the value at that index operation. That means what we'll do is 214 base 8 can be converted into, so 2 into 8 square plus 1 into 8 power 1 plus 4 into 8 power 0. Now this will be, so 128, 64 into 2, 128 plus 8 plus 4. So how much it is? 140 to the base 10 here, decimal number. So answer is A here. And the next one, a single transistor can be used to build which of the following digital logic gates? So single transistor, as we discussed earlier, single transistor can be operated in 3 modes of operation. What are they? That is, the first one is active mode or active mode, and the second one will be saturation mode, and third one will be cutoff mode. Okay, so in the modes, among these modes 1 2, let me 1 2 3 here. Among the modes 2 and 3 can be used for switching operation. So switching operation means when the transistor is in cutoff region or saturation region, it can supply the current or it can block the current. Okay, at that time it act as which element here it is? It's a NOT gate. Okay, single transistor. Multiple transistors means we can apply, we can use it for all other gates. Okay, next one. Power factor of a transformer on no load is poor due to. Okay, the power factor of the no load transformer, as we discussed in my previous videos, it is cos phi is equal to cos phi naught is equal to around 0.2 here. Okay, so this will be 0.2. This is because the magnetizing current of the transformer. That is the reason why the current is a very high, power factor is very low here. Okay, so A is a right answer for this question. So if you are getting A answer, it's right. The next question is, the instruction that represents rotate source count is. Yes, the answer for this question is D. Okay, all of them mentioned here. The rotate source count is a group of 4 instructions containing RCL, RCR, ROL, ROR here. Okay, next question. The instruction that performs logic and operations and the result of the operation is not available is. Okay, the answer for this question is test. Okay, in the test instruction, the logical and operations is performed and the result is not stored, but the flags are affected. So it's going to affect the flags here. Next one, which of the following voltage to frequency converter multi-vibrator? So here it is nothing but a stable multi-vibrator. So answer is B here. Next one, the absolute jump instruction is intended mainly for a jump within a memory space of. So within a memory space, the absolute jump instruction is intended mainly for a jump within a memory space of. Yes, answer is 2 kilobytes here. Next one, which of the following filter transformation is not possible? Okay, the answer for this question is high pass analog filter to high pass digital filter. Okay, and the next one, 27th question here. Which of the following operations performed by the blocks given the figure below? Okay, so here the correct answer for this question is it is a sampling rate conversion by factor of IO. Next one. So Chebyshev polynomials of odd orders are. So they are odd functions. So 28 is a B is the answer. The expansion of DA is. So DA is nothing but decimal adjacent accumulator here. Next one. The digital system includes. So digital system includes the better encryption and easier data manipulation. Okay, the answer is better encryption algorithm. Next one. Which of the following series has ROC as mentioned below? So it is alpha to the power n into u of n here. Next one. What is the convolution x of n of the signals x1 of n is equal to 1 comma minus 2 comma 1 and x2 of n is equal to 1 comma 1 comma 1 up to here. Okay, so the convolution between two signals is x1 of n, so x1 of z into x2 of z is equal to, okay, so first I will write x1 of n here, can be written as 1 minus 2 into z power minus 1 plus z power minus 2 here, and for this case it is 1 plus z power minus 1 plus z power minus 2 plus z power minus 3 plus z power minus 4 plus z power minus 5 here. Okay, so when you are performing the convolution between the two signals, the resultant will be 1 minus z power minus 1 minus z power minus 6 plus z power minus 7 here. That means the convolution of this x1 x1 dash into x2 dash is equal to x2 of z is equal to, it will be 1 comma minus 1 comma, so 1 2 will be there, 0 comma 0 comma 0 comma 0 comma minus 1 comma 1 here. Okay, the answer for this question here it is D is the right answer. Next one. If SUB subtract B, A comma R4 is executed, then actually what operation is being applied here? Okay, so when SUBB subtract B, command subtract with a borrow the content of the accumulator with that of the resistor or some immediate value. So A minus R4 is done here. So this is the answer for this question here. Next one. A single phase short transmission line has a reactance of J0.8, comma supplies a resistive load of 500 amps at 300 volts. The sending in power factor will be. So to find sending in power factor here, so first we need to find R value. So R is equal to resistance of the load is equal to V by I. It is nothing but 300 divided by 500. It is nothing but how much? It is 0.6 ohms here. Now find the impedance value. Z is equal to square root of R square plus XL square. Now what is Z value here? So Z value to find. So square root of 0.6 whole square plus 0.8 whole square. You will get it as a 1 ohm here. Okay. Now we'll get a Z value, RL value. Now power factor. So cos phi is equal to R by Z is nothing but 0.6 here. Okay. Now the transmission line reactance of inductance into reactance, so 0.6 lagging is the answer. Next one. The transmission network of a short transmission line will have a transmission line parameters of, if you take the ABCD parameters for a short transmission line, 1 Z C0 D1. So 1 Z 01 is the answer A. So hope you are getting the answers. Next one. In a 3-core cable, the capacitance between the two conductors with the sheath earthed is 1 microfarad. So in a, okay, here 3 conductors are there. Okay, they are sheath is earthed here. Okay, now the capacitance between the two conductors is this C. Okay, CL you can take CL. Okay, CL is how much? 1 microfarad. Now what about the capacitance per phase? So generally capacitance is divided into two parts, means Entire capacitance value will be CL. Midterm means half value means it is nothing but it is CPH. So CPH is equal to 2 times that of CL. So answer is D. So hope you are getting the answers here. You are getting next. Next one. That's one question. In a 3-unit insulator string, the voltage across the lowest string is 10 kV and the string efficiency is 90%. Then the total voltage across the string will be. Yes, guess the answer. Now answer is it is string efficiency. We'll take it terms of percentage here 100. Now 0.9 into number of disks are how many? 3 into what we need to find. Lowest disk is 10 kilowatts, so 10 kV is equal to VT. Now 0.9 into 3 means 2.7 into 10 kV means okay 27 kV is the answer. So we're getting the answer as 3. Okay, we're getting 27 kV is the right answer. So coronal losses will increase with. So coronal losses is going to be increased with the decrease in the conductor size and increase in the supply frequency. So why it is sir? So P is proportional to F plus 25 and P is proportional to V PH minus VC whole square. As we are decreasing the radius of the conductor, now decreasing the conductor size, automatically VC value will increase. So VC value will decrease. As VC increase, VPH minus VC value whole value increases. Okay, so answer is C. Next one. Okay, 13th question. The off diagonal element Yij of a bus admittance matrix is equal to. Okay, so if you take the admittance matrices here, okay, so let me take y11, y12, y1, y2, y13. Okay, so y21, y22, and y23, y31, y32, and y33. Now, if you take the diagonal elements are these values only. But actually, off diagonal elements means that they will have a minus sign here, minus value, minus, minus, minus here. Okay. Now, what they are asking is the off diagonal elements of Yij of a bus admittance matrix is equal to minus of the admittance connected between the buses I and J. So between the buses I and J means 2, 1 or 1, 3 like that. So answer is C. Next one, 40th question here. Okay, so we are moving forward in the 40th question. And I collected these questions from various sources of internet as well as previous assistant engineering examinations of EPPCL and AP Transco and AP Genco papers. Okay. 40th question. The number of iterations will be least in the following methods to obtain the load flow solution. Okay. So tell the answer. The answer it is D. Newton-Raphson method, where the iterations will be less, but the time taken to solve the iterations is more in case of Newton-Raphson method. Next one. 41 question. In a in a single line to ground fault. So SLG means single line to ground fault. In conventional phases, the phase sequence components or current are equal. The positive and negative components of the currents are equal, and zero sequence components of zero. All the sequence network will be in parallel. All the zero sequence components only will be present. So if you take the sequence network of this single line to ground fault, only positive sequence voltage will be there, negative sequence and zero sequence will be like this. So they all are connected in series. Okay, so the sequence components of current are equal. So that is IA naught is equal to IA1 is equal to IA2. So zero sequence current is equal to positive sequence current is equal to negative sequence current. All are same. Okay, so answer is A here. Next one. The ranking and severity of the fault can be written in ascending order as follows. Okay, in ascending order, LLG fault will have more severity compared to LLG. Okay, and LLG is having more severity compared to LL, and WL is more severe compared to SLG. So answer is D here. 42. D is the answer. Okay, so hope you are getting the answers. So write in a piece of paper how many marks you are getting. Okay, at least how many questions you are attempting and what are the weak areas you are facing here. And focus on that weak area so that you can gain good strength in the examination and you can crack your dream job. Okay, next question here. If the inertia constant is 4 megajoules per MVA and the rating of the generator is 10 MVA, the energy is, so inertia constant H is equal to, so kinetic energy stored divided by MVA rating here. So I want the kinetic energy. So kinetic energy is equal to inertia constant is how much? 4 into 10. So answer is 10. So 10 into 4 means 40 megajoules is the answer. Okay, hope you're getting the answer as A. Okay, so these are the simple questions only. In examination, approximate will be there, but little bit tough. Okay, so be ready for a tough exam. As a first model paper, I am just giving a basics questions. Okay, and it depends upon your views and comments. I will make the next model paper. Okay, it depends upon you, not me. Next question. The critical clearing time of a fault in a power system is related to. So critical clearing time is in a power system related to, it says transient stability. So when the critical clearing time, it is the time it is used for the circuit breaker to operate the current, to operate the fault current here. Okay, so the answer is for this question is transient stability limit. Okay, next one. 45th question here. In an IDMT, what is the IDMT? So inverse definite minimum time, okay, relay. The electromagnetic overcurrent relay with a minimum time is achieved because of, minimum time means there are two settings are there. First one is a plug setting multiplier and second one is time setting multiplier. So we are adjusting with the time means we can use the help of TSM. So approximate time delay element here. So that the answer is C is the right answer for this question. Okay, next one. The relay used for full protection of short transmission lines. Okay, now guess the answer. The answer is reactance relay is used for the short transmission lines, impedance relay for the medium transmission lines, and the more relay is for long transmission lines. Okay, so we hope you are getting the answer as B for this question. And for suppose if the same question is asked, the relay used for the full protection of short transmission lines is reactance relay. Suppose here instead of short, if it is asking medium, then you can say it's an impedance relay. Instead of asking a short here, if they ask more long transmission line means you can use go for the more relay here. So in the same question you're getting three answers. So three answers for different questions here. And we'll start the questions from the control systems, right? Control systems also very important. In the last year TNAP paper, as you're seeing, almost most of the questions are from the control systems. Very important questions and very conceptual questions they asked. Okay, but this year paper will be of 60 questions only. So I hope that important topics they are going to cover. Okay, not all the topics as a previous 120 questions. Okay, they are going to ask 60 questions only now. Okay, right now. So the number of forward paths in the following signal flow graph is, so forward path is the one which starting from the point starting node to the ending node here. Let me take A and B. So in between A and B, I can start going from here as A. I'll D, E, F, B is a one forward path. Second forward path, I can go here A. There is no possibility C is reverse direction. I can go to D. I can go to G. Okay. Second is A, D, G. And the third point. Okay. Third one. Is there any third one here? C. Is there any possible to go right? Yes, here it is. E can go E and H. Okay, so similar kind of question is asked in SPDCL, AP SPDCL exam, AE paper in 2014. So the solutions of this AP SPDCL 2014 paper is available in my channel. You can just search it AP SPDCL papers. You can get the previous paper also. Okay, so it will have 100 questions of technical. Okay, those who are new to my YouTube channel, you can subscribe to my YouTube channel for more updates, and you can go through the lots of previous year question papers are there. Okay, you can use it. So the answer is here it is a right option for this question. Next one. Okay, right. So there is a one more question from the control system here I taken. The open loop transfer function of a unity feedback, that is a negative feedback mentioned here, system is g of s is equal to k divided by s into s plus 2 into s square plus 2s plus 2. Then the closed loop transfer function for k is equal to 1. is, no, we need to find a closed loop transfer function. So closed loop transfer function is equal to open loop transfer function divided by 1 plus open loop transfer function. Now take this open loop transfer function here. Okay, if you are and taking this value and substituting k is equal to 1, so directly I can write here, so 1 divided by, I'm directly writing substituting this equation, will get a 1 divided by 1 plus s into s plus 2 into s square plus 2s plus 2 here. Okay, now if you solve this, so solve this and tell me the final equation here. Check the final equation. So I'm writing the equation, final equation of this will be, so it is similar to that of 1 by s plus 1 whole square into s plus 1 whole square. If you want, you can cross check. So the answer will be 1 by s plus 1 whole to the power of 4. Okay, you can cross check, you'll get the same answers here. So answer here it is, B is the right answer for this question here. And next question, it is also important question. The overall transfer function of the following system is, so instead of doing this solution by using block reduction technique, I can use the signal flow graph to get the answer for this problem here. Okay, so how to do this, sir? So do on your own piece of paper and tell me the answer. Anybody got the answer? Yes, if you're getting the answer as 1 minus 1, then you are right. Your concept is absolutely clear. Now, so if you want to, if you write the transfer function by using the Madison's gain formula, the transfer function is equal to number of forward paths is g of s divided by, how many loops are here? There are two loops are there. Okay, first one is g of s into 1 by g of s. So what you'll get? So 1 minus, now sum of individual loops. So here if you solving this, what you'll get, g of s into 1 by g of s. So one loop. Okay, there is another loop is here, they are not touching here. Okay, so this loop will be like this. Now this loop will have a feedback of 1. Okay, so sum of individual loops will be like this. Now g of s gets cancelled. 1, sorry, here you have g of s, sorry, g of s. Okay, now the transfer function I'll write here is equal to g of s divided by 1 minus g of s into 1 by g of s minus g of s. So g of s gets cancelled. 1 minus 1 is going to be cancelled here. So enter here finally g of s divided by minus g of s. So gets cancelled, minus 1 will get. So minus 1 is the right answer for this question here. Okay, we'll move to the next question here. Now, okay, right. The open loop transfer function of a unity feedback, positive feedback here, they mentioned that it's a positive feedback system is, so g of s is equal to k divided by s square plus square plus 1 whole to the power of square. Okay, is the system is stability according to Routh-Harvest criteria. So first we'll take the transfer function, closure transfer function, 1 plus or 1 minus here. So they said positive feedback now. So 1 minus g of s into h of s is equal to 0. Now based on this, so s square plus 1 whole square minus k is equal to 0. Now s power 4 plus 2 s square into 1. I'm just applying the a plus b formula here. A square plus b square plus b square plus 2ab minus k is equal to 0. Now s power 4 plus 2s square plus 1 minus k is equal to 0. So if you write the RS criteria table, s power 4, s cube, s square, s power 1, s power 0. So I'm making the RS tabulation here directly. Now s power 4 is 1 first term, and next term will be 1 minus k. What about the s cube terms are zeros? Okay, so when they are zeros, okay, let me correct here a small mistake here. Okay, right. So here in this equation s cube term is 0. Okay, so as s cube term is 0, so 2 will become here, so 2 here, and next it will be s squared terms are there, so 2 is here, and 1 minus k is here. Okay, let me correct here, mistake is done. Okay, okay, excuse me, I will make the correction here. So a small confusion. So first s power 4 plus, here one term is missing, I'll write the term as that is some s power 3 term plus already general terms here. The general terms are 2s square plus another term is missing here. The term we name it as s here. Okay, now plus 1 minus k is equal to 0. Now based on this, s power 4 2s square 1 minus k will come in the first row. Okay, so here we'll get it as 1 minus k here. Okay, this s cube term entire is 0. S cube is here, s power 3 is 0, s is 0. So here you are getting a 0 terms here. Okay, now next s square terms. So how to get this s square terms here? Now s cube is there, so we'll take the auxiliary equation here. Now auxiliary equation of this one is to get this s power 3, we will take the auxiliary equation s power 4 here. So that is s power 4 plus 2 s square will be 0. Okay, this is our auxiliary equation. So d by d s of auxiliary equation, you get it as, so 4 s cube plus 4 s. So here we may get replace this with row with what, as it is a 4, and here also we get a 4 here. Okay, now again here s square term. So to get s square here, what you'll get is you'll get 0 terms. Okay, what about the s square term here? So next is we'll class multiply here. So 8, 4 2 ja 8 minus 4 divided by 4 here, and your by class multiplication here you will get a 1 minus k here. So here you will get a 1 here. Now here is for one term. Okay, 1 into 4 4 minus, okay, minus 4 plus k divided by 1 here. So you will get a 0. Now 4 minus 4 means just only k here. Okay, so in this first row all the coefficients are positive, so that means there is no pole on RHS. Okay, but the system is stable. No, it's not completely stable, it's a marginal stable for the k less than 0. So from this we can say if the k is a positive value, we can say it is a marginally stable system. Why? Because we found the auxiliary equation values. So answer is marginally stable here. Okay, we'll move to the next question in this series of lectures. Next one, 51. The poles and zeros of driving point impedance function are simple and interlace on the negative real axis with a pole closest to the origin. It can be realized. So it can be realized by using a RC driving point input impedance. So RC driving point impedance here. So answer for this question is C. Next one. And now we are discussing from the topic of power electronics. Now, the main advantages of insulated gate bipolar transistor over an SCR in power electronics is, so IGBT is a self-commutating capability, or we can say IGBT is a fully controlled switch. Fully controlled switch, and SCR is a semi-controlled switch. Okay, so from these options, IGBT is a self-commutating capability. It is having a self-commutating capability when compared to SCR. Okay, next one. A PWM switching scheme is used with a three-phase inverter. Okay, so to reduce the total harmonic distortion. Tell me the answer for this question. Minimize the load on the DC side, increase the life of the batteries, reduce the lower order harmonics, and increase the higher order harmonics. So the answer for this question is D is the right answer. Why it is? Because the lower order harmonics will have higher values of magnitude. So higher magnitude of disturbance or harmonics. Okay, so which is very difficult to filter out. Okay, so lower order harmonics will have higher magnitudes of the harmonics. And what the PWM technique? There's a pulse width modulation technique. So PWM means pulse width modulation technique. So by using this pulse width modulation technique, we are reducing the lower order of harmonics and increasing the higher order of harmonics. Sir, why you are increasing the higher order harmonics? So if we increase the higher order harmonics by using the filters, by use the active filters or passive filters, we can eliminate these harmonics easily. Okay, and one more question from here: which of the harmonics are easier to eliminate? Is it lower order? Is it higher order? Yes, it is higher order only. So higher order harmonics are very easy to eliminate with the help of filters, but the lower order harmonics very difficult to filter. Okay, that's the reason why by using this pulse width modulation technique, we will intentionally reduce this lower order harmonics. Okay, so the lower order harmonics may be 3, 5, 7 like this. Okay, next one. A chopper circuit is operated with only one positive load current. Choose the correct statement here. Okay, so see the circuit diagram here. So see, type C chopper is operated with only positive load current. So positive load current means the current has to flow. The current has to flow from here to load. Okay, so okay, load for the current has to flow like this. Now see here, when it is in a regenerative mode, then this load has to flow like this. So entire these switches 1 and switches 2, that is CH1 and freewheeling diode, so both are continuously on for positive load current. So positive load current here. So for positive load currents, the current has to flow like this. Okay, the D2, the operating switches here, that is a D2 and the CS2 should be completely off. So D2 and CS2 is in off condition or remaining idle condition. So the answer for this question is, as you can see, D2 and CS2 will be remain in ideal. Next one. 56th question. The control strategy in which on and off time are guided by the previous set of values of a certain parameter is called. Generally, if you see the previous TNB paper, there is one question on the current limit control. So where the current is changing like this waveform. Okay, these points, reference points, are set by current limit control. So where the current is going to be controlled by this current limit control, where this waveform should not exceed, go on like this. It has to be controlled, current limit control we are going to use. So we will set as some maximum value, we will set some minimum value. In this maximum value and minimum values, in this minimum values only, the current has to flow. It should not go beyond maximum value, it should not be below the minimum value. That is the reason why we are using here current limit control. So current limit control is a right answer for this question here. Next one. For a power transistor, if the forward biased current gain alpha is equal to 0.97, then what is the beta value? So here we can use a relationship to get the answer. Alpha is equal to beta divided by beta plus 1. Now we know that alpha is 0.97. Substitute the value here. 0.97 is equal into 1 plus beta is equal to beta here. So 0.97 is equal to, so beta of 1 minus 0.97. So by solve this value, beta is going to be 32.33. Okay, so the answer is 32.33 is the right answer. Okay, next one. So in this problem, what is the voltage across the R load when the T1 is conducting? So here V1 is nothing but Vs by 2 and V2 is also Vs by 2 here. When the T1 is conducting here like this, whatever the voltage will appear here, the voltage appears going to be Vs by 2 is the right answer. Okay, and we'll move forward here. Next one. Now we came to the last of this lecture here. Okay, so before completing these questions here, once completion of this video, please like the video and share with your friends, and also share your marks out of 60 questions or 60 marks, how many marks you're getting. So don't go for the negative. Okay, just count yourself and put your marks in the comment box here. Okay, the reverse recovery time of a diode is TRR is equal to 3 microseconds, and the rate of fall of diode current dI by dt is 30 amperes per microsecond. Now determine the storage charge. The storage charge Q, or we can also reverse recovery charge QRR is equal to half into di by dt into TRR square. Okay, so using this formula, half into di by dt is how much? It is 30 into TRR square means 3 square, all in microseconds only. So how much you get here? So 15 into 9. Okay, it's going to be 135 microseconds here. So it is why, because when you see the characteristics of the diode, the current will be here like this. So we need to find this charge here, and the current is I-axis and T is on time axis here. Okay, so by using this graph here, we can find the answer. Okay, it is 135 microseconds here. So answer is B here. Okay, next one, the last question. For an SCR, conduction angle is 120 degrees when average on state current is 20 amperes. Okay, so when the conduction angle is halved, the earlier value, the on state average current will be. Okay, so the answer for this question is the answer is D, is less than 20 amperes. So why it is, sir? It is based on the formula that form factor. So form factor is nothing but it is a ratio of average value, sorry, maximum value, RMS value to average value. So I average value on state current is equal to IRMS value divided by form factor. So form factor for 120 degrees conduction mode, it is 1.878 is the standard value. Just remember this value. So for 60 degrees, it will be around 2.781. Now as you can see, as the form factor value increases, average value is going to be decreases here. So from this conclusion, we can say that it is less than 20 amperes of current. So that's it, friends. Thank you for watching my video. And if you like this video, please subscribe. And if you want more videos also, you can subscribe to my channel, and you can comment here and share with your friends. Your sharing and your comments and your subscriptions will make me to do more and more for you. Okay, so all the best for your exam preparation. Thank you. Have a nice day.